The easiest way to simplify anything is to do the parentheses first. That's what we learned when we did PEMDAS, right? Okay, so is everybody okay if I distribute in the parentheses first? Because it's going to be one less step than what you had. What you did was fine, but this is one less step. So I would do inside first. How do we reduce 12 over 10? Let me ask y'all a question. Can you do 12 divided by 10? No, but you can simplify it. So what number goes into both 12 and 10, y'all?
2.
2. So if you go ahead and divide these by 2, the numbers get a lot smaller, y'all. So let's look at this. What's 12 divided by 2? 6. What's 10 divided by 2?
5.
All right. Let me keep going. Okay. Well, I'll get the same thing you got, but this way is one step shorter. You weren't wrong. This is one step shorter though. You had like 4 or 5 steps. I'm gonna do it in 3. All right, I reduced 6 over 5. Now, what did we learn yesterday about negative exponents?
You have to flip it.
Good. You can't. If I told Amaya to go clean her room -3 times, that does not make sense. If I told Curtis to brush his teeth -2 times, I hope I wouldn't have to tell you to do that. But that don't make sense. So you should have learned yesterday, if the exponent is negative, you move it to the other side and change the sign, right? Okay, so y'all look, I'm going to move the x to the -3rd to the bottom and make it positive. So let's look at the bottom now. How many x's are in the bottom? 4. Is Tay the only person that can count? And Gwyneth? I'm not trying to be super mean to y'all, but I'm a little upset that we didn't know how to do this because there are ones like this on your test and I'm leaving it today. X to the 4th. There's 1 x already down here and we have 3 more now once we moved this negative exponent, right? Anybody confused about that? Michael, you okay? Y'all make sure you're asking questions because apparently y'all doing problems with people yesterday did not help. That's fine. I'll go handle it after school. I had a feeling. I hate it when people can't follow directions. All right, look at your Y's. What do we need to move?
The -2 to the top.
Good. Okay, there we go. There's my children. The -2nd. You can't have a negative exponent. Where do we move it? What'd y'all say?
The top.
To the top and make it
+2.
So how many Y's do we have in the top now?
9.
9. Michael, ask me a question, baby, because you already look confused. I'm not trying to put you on blast, but I want to make sure you get it. We got 9 Y's in the top. You simplified the inside, y'all. Look how much easier this looks now. So much easier. Do the inside first because I'm about to finish this in just one more step. Okay? I recommend doing the inside first. A lot of you distributed the exponent of 2 first. That's fine, but you did 2 extra steps than I'm going to have to do. What questions do we have about simplifying the inside? Y'all are okay? Yeah? Okay, what's your question if you're saying no? What part stumped you? After the divide, what are you supposed to do with the exponent outside?
Add.
Distribute it in. We don't add it. We don't subtract it. It's with parentheses. You got to carry it into everything. That's what we learned yesterday, right? Okay, carry it into everything. Do y'all agree that's 6 squared? How many Y's do I have now? Good, Tay. 18. How'd you get 18? They're looking at me funny, so I'm making sure.
6 times 2.
9 times 2. We distributed. Good. Okay, look on the bottom. We got to take the 2 into the bottom as well. So now that's 5 squared. And how many X's do I have on the bottom? Somebody different. There we go. Are we okay with that? I know you were shown to take the 2 in first. It should be easier to do the inside first. I don't care if you take the 2 in first. You'll get the same thing, but it's an extra step or 2. So now that's the only thing we got left to do. I hope you were told this yesterday. I'm so proud of you. You already got 4 extra credit points today. Good job, girl. What is 6 squared? If you say 12, I'm throwing a calculator at you.
36.
Good, Gwyneth. 36. Don't you put 12 on that test. What's 5 squared?
25.
25. It means 5 times 5. So this should have been your answer. That should not be that bad. When you get to Math 2 next year, you're going to have to know how to do these. So I'm about to give y'all another one. Any questions on number 1? Yes. Which part? You got to be specific for me. 6 squared means 6 times itself 2 times. So 6 times 6 is 36. That's a good question. No, that's a great question. I need everybody to pay attention right now. Put your pencil down. Eyeballs on the board. Whatever she did with y'all yesterday was just a complete waste because y'all are back where I left you on Tuesday. I'm so upset. It's okay. Are we paying attention? Okay. This is not the same thing as this, and I want everybody to watch. We're going to compare these. These are not the same. First of all, I hope you can tell the parentheses are over the whole thing in the blue one. Yes? Okay, we're going back to Unit 1. Chandler, close your computer, baby, so I know you're paying attention. I shouldn't need to go over yesterday's assignment since it was done for y'all pretty much. Think about PEMDAS, parentheses first, exponents next, multiplication and division in the same step, addition and subtraction if you've got the nerve, from left to right, first come, first serve. Do you remember the rap I showed you on day 1 of this class? Nobody remembers that rap video? You do. Okay. Good. Okay, so pay attention, y'all. Parentheses first. In the blue one, this is like what we did on the front. If you can do the whole parentheses, that's what you do first. And in this one, you can. So a lot of y'all that did 4 divided by 2, that would work in the blue one. Does that work in the black one?
No.
No, babies. The parentheses are only in the top. So let's look at the parentheses of this black one. Can you do 4a cubed b to the negative 1?
No.
No, because a 4 can't combine with an a. They don't both have an a. And a can't combine with a b because they're not the same letter or base. They're not the same. So we can't even do parentheses first. What comes next? Exponents. You should have taken the negative 2 in. Now, I love y'all dearly. I literally just did one with you where we took the exponent in. So if you're still struggling, you need to come to tutoring today. If you can't come to Zoom today, then you need to come to school early tomorrow and I can help you in person. Do we understand? All right. If you take this negative 2, and I want y'all to watch, that would be 4 to the negative 2. How many A's do I have if I do 3 times negative 2?
Negative.
There we go. I heard negative 6. Good job. How many B's do I have if I do negative 1 times negative 2? Positive 2. Y'all, parentheses in math have always meant the same thing. Parentheses mean to multiply. So you got an exponent outside of parentheses, you're going to multiply. Are we okay with that?
Yeah.
Okay, now y'all listen. Does the bottom have anything to do with the negative 2?
No.
No, Chandler's grinning at me. You know I love y'all dearly. I'm not pissed off at y'all. I'm a little irritated with you know who. It's fine. I'm an adult, so I'm going to go handle it. I'm just going to bring it down. The negative 2 has nothing to do with that denominator, with that base. Okay? The bottom part had nothing to do with it. The negative 2 was just in the top. So all I did was brought the bottom down. Now from here, we should be okay. Michael, you paying attention? Don't fall asleep on me. I'm going to throw something at you. What do we do next? We just did exponents. Is there any multiplication to do? Y'all don't know. Why am I saying we don't know? You don't know if there's anything to multiply because we actually didn't finish here yet. What kind of exponents can I not have?
Negative exponent.
Okay, y'all learned something yesterday. There we go. You can't have negative exponents. If the exponent is negative, what do you do with it?
You change it and
Flip it. You move it to the other side and make it positive. So everybody look. Y'all agree that's a negative exponent.
Yeah.
So I'm going to move the 4 to the negative second where?
To the bottom.
To the bottom and make it
+2.
There we go. Not, I don't care what she did. I want you to watch. 4 squared. It's on the bottom now. We moved it, made it positive. Are y'all okay with that?
Mm-hmm.
Okay. What else is negative? I see some other stuff we have to move.
The -6.
Good. Does everybody see a to the -6? We
Yeah.
got to move it. It's negative. Where are we going to move it?
There
we go, y'all. Okay, so y'all learned some stuff yesterday. Move it to the bottom, make it positive. Right?
And then the -3.
Good, Gwyneth. And then Gwyneth said b to the -3rd. You got to move to the top and make it positive. So now I know it looks kind of crazy the way I have it, but I color-coded everything for y'all. So I'm going to mark through everything we just moved. We don't need that. We don't need that. We don't need that. Can we simplify what is left?
Yeah.
I hope so. I'm going to be very upset. I'm already a little pressed is a good word. In the top, how many B's do I have?
5.
We'll be careful. Don't multiply and put them together. So 2 and 3 makes 5. Very good. So B to the 5th over. Let's talk about the bottom. How many A's are in the bottom? 11 A's. Curtis, I'm doing good so far, right? You got the answer back there. What's 4 squared?
16.
Good. Do not tell me 8, Michael. It's 16. 4 squared means 4 times itself, 2 times. 4 times 4 is 16. Y'all, what's 16 times 2? There we go. You should have gotten B to the 5th over 32A to the 11th. I'm pissed off too, because it was like nothing happened yesterday. Listen, just hang on. Let me pause my recording because I'm talking junk and I don't need to. If you still need help with problems like that, come to tutoring. I'm clapping, I'm dancing, we'll hit the whoa, whatever. Get your butt in the tutoring. Do we understand?
Yeah.
It is on Zoom, 4 to 5. You can join and be like, hey, Ms. Poole, can you just give me a problem to try? And if you get it right, I'll let you go. Okay? Zoom, 4 to 5, baby. I have Zoom office hours where you can come for help every day from 4 to 5. And if you can't join 4 to 5, all you got to do is shoot me an email. I'll join at another time with you. Some of y'all don't even try to come, though. It irks me. Nice. I don't want you to have to copy it. All right. Unit 3 vocab. So y'all listen very carefully. We're going to go over the first half today. We're going to do the second half tomorrow. Does that sound good? Your Unit 3 vocab cards are due. Does anybody know when? I'm going to bring you one, baby. Anybody know when? Close. I always give you a week. So when are they due? Next Thursday, baby. Today is Thursday. They all said Friday. Good grief. All right. Most of you do. You do too, Skylar. Skylar looked upset. She was like, what? All right, listen. The coefficient is the number in front of the variable. Hey, give me a variable. X. Skylar, give me a number. 100. She had to pick a big one. Curtis, give me another number, baby. 2. Everybody pay attention. Which of those is the coefficient? 100. Guess what? You can put that right on your card. You can use this example. Write it down with me. The coefficient is the number in front of the variable. So that would be 100. What's the base of this expression? What's attached to the exponent? The x. Everybody look. The base is whatever is being raised to the power. So that would be the x. Michael, I hope you're writing this down. Okay. I'll worry about you in a good way. The exponent is the number of times the base is being multiplied by itself. Now, I hope y'all all know that the exponent would be 2. If you mess that part up, we're in trouble because we did this on Tuesday and Monday. So we all understand what the coefficient, the base, and the exponent are, right?
Yeah.
Okay. You can use this example on your cards, and listen, on your cards, you can literally put 100x squared for all 3 of these. And for the coefficient, you can highlight 100, make it bold. For the base, you can highlight x, make it bold. For the exponent, you can highlight the 2, make it bold. Does that make sense?
Yeah.
Do we need to talk about some synonyms? What could your synonym for coefficient be? I kind of gave it to you already. The number. Some people like to say in front. That's fine with me too. Both of those could be synonyms for coefficient. The base, I've seen all kinds of things for base. So every year I have a kid that says being raised. That's perfect. I also have kids that'll say the bottom, because it's like the bottom and the exponent is like the top. I'm cool with that too. That's a good synonym for base. I also have kids every year that tell me the base is the variable. That's good too. So you got some synonyms you can use for your cards, okay? All right, what's a synonym we could use for exponent?
The power raised.
Oh, power. I like that. Power. What else did you say, Gwyneth?
Power raised.
Raised, good. I always have a kid that says index, because you know an index is like something that's at the top. Yeah, if you didn't know that, now you do. You learn something new every day. She said, all right, power raised index. Those are all synonyms for exponent. So we're going to do 2 more, and then we're going to stop with the vocab today, and we'll finish it tomorrow after we've done some exponential stuff today. So it'll make more sense. These next 2, super important, and you should already know linear functions. So this next one really is the one that is new. So I'm going to grab a different color. An exponential function has a multiplying pattern. That is brand new. You guys have never seen exponential functions before. It's my job to teach you about them. I like them. They're a lot easier than linear. You guys are going to like them, I guarantee you. It's like my favorite thing we teach in here. Okay? Exponential functions have a multiplying pattern. Let me tell you why. Whenever you have an exponent, that tells you how many times you're doing what to the base? Multiplying. Ding, ding, ding. Winner, winner, chicken dinner. If it's an exponential function, you are multiplying. Now look, y'all, I even gave you the equation. That can be your example. Does everybody see how it says y equals a times b raised to the x?
Yes.
That's going to be our new mx plus b. You're going to have to know that a times b to the x like the back of your hand, okay? Now, linear function, we shouldn't have to go over. I really hope y'all remember a linear function has a constant rate of change or an adding pattern, and it's y equals mx plus b. We know that, right?
Yeah.
Okay. So the other vocab words I will go over tomorrow because I want to make sure y'all have some kind of like homework time today. Does that sound good?
Yeah.
All right. Any questions on vocab? Page 25 is where you're going to put your Unit 3 vocab list. Not now, later. So when we're done with notes, I will pass out staplers and tape, and you can put your vocab list in there that I just gave you, okay? Page 26, today and tomorrow's notes. So what we do today and tomorrow is going on page 26. We're going to be talking about exponential functions. All right, exponential functions. What did we just say in the vocab? Exponential functions will have what kind of pattern? You can look at your sheet if you need to. Good job, Tay. Multiplying. So this is what we're going to do first. We're going to compare linear functions versus exponential functions. We're going to make a little chart and we're going to compare linear versus exponential. I want y'all to copy that chart down and we're going to start comparing. All right, linear functions. What was the equation of a linear function? If y'all don't tell me that y equals equation, I'm going to be upset.
Y equals mx plus b.
There we go. Some of y'all looked back. That's a little scary. Y equals mx plus b. So let's just review. What did the m stand for?
Slope.
The slope. Good job. What does the b stand for?
The base.
The base. Y'all are so smart. So we remember linear functions, right? Okay, do you guys remember linear functions have straight line graphs? Right? If you graph a linear function, it makes a straight line?
Yeah.
Yeah, like if you graph a line, it will be straight, correct?
Yeah.
Okay. Y'all looking at me like I made that up on the spot. Good guy. Jay, all lines are straight lines, right, baby? All lines will be straight lines? Okay, good. So linear functions are straight lines. Ooh, I'm worried about y'all today. The other thing we need to know about linear functions, they had an adding pattern. And a constant rate of change, right?
Yeah.
And rate of change means the same thing as slope. So that should all be reviewed. So graphs of lines are straight lines. They have an adding pattern. We rise over run, right? Constant rate of change. When you're not here, so at that point I can't help you. All right, exponential functions. Look at your vocab sheet. We just talked about it. What's the equation of an exponential function? Look at your sheet.
Y equals a b squared.
Times b raised to the,
Squared.
no, it's not a 2. Look carefully. Thank you. It's an x. It's not squared. That's where the x will be. Now let's go ahead and talk about this. The x is in the exponent. That is why it's called exponential. The x is the exponent. In an exponential function, the x is the exponent. That's why it's called exponential. It's brand new. You've probably never seen this before.
No, I'm saying like, so the exponent will always be a
It is always the x. So whatever value they tell you to put in for x, that's where it'll go. So like, let me give you an example. That's fine. We can write an example. 3 times 2 to the x. That's exponential.
Do we do a squared plus b squared equals c squared?
No. Nope. And that's not anything to do with exponentials because they're all squared. You'll do that in math too when you do geometry. Exponential functions always have x as the exponent. If you don't see x as the exponent, then it's not exponential. Does that make sense? Okay, we're comparing these to lines, so y'all listen very carefully. If I have x as the exponent, do you think it's going to end up being a straight line? No. Let me go ahead and tell you about exponential functions. Exponential functions grow really fast or they go down really fast. They do expand. So watch. The graphs, write this down. The graphs are not straight. They're going to look something like this. They kind of make like a J shape. And we'll talk more about the graphs tomorrow. What we're focusing on today is the equations and the tables. Kind of, not really. So parabolas have matching sides. They're symmetrical.
Oh,
Exponential graphs either shoot up or they shoot down. That's it.
Is there any solving we have to do with these?
Is there a what?
Any solving we have to do?
Not in Math 1, no. Nope, you will solve exponential functions in Math 3. So look, the graphs are not straight. They also, since they're not straight, do not have a rate of change. Because what do we know about a rate of change? What do we write over here in front of the word rate of change?
Constant.
It's constant. Y'all, you can only have something be constant if it's a straight line. So these exponential functions are not going to have a constant rate of change. And then the last thing we talked about it when we did vocab, what kind of pattern should these have? What sign do you see in the equation? There we go. Have a multiplying pattern. I'm gonna let y'all write. Okay, so let's dissect this even more. Y'all ready? Y equals A times B to the X. We're gonna talk about what each part means, what each part represents. So I'm starting off just like we did with linear. When you guys first came to me, when we first learned linear functions, we talked about what the M meant and what the B meant. And then we went from there. So what I need y'all to remember, this is completely different from linear. The B no longer means the base. B is not the base anymore, okay? And there's no M, so there shouldn't be any confusion. But I always have a kid try to tell me A is the slope. There is no slope, it's exponential, all right? So I just want you to write this down. The A, this is where your initial amount will be. The B is your factor. Exactly. Good question. I always have a kid ask me that. So what she said, I'm going to say it for y'all in case you couldn't hear. She said, what do you mean by factor? Do you guys remember, Curtis, you with me? You guys remember back in like 6th grade, 7th grade, where your teacher would say, what are factors of 12?
Yeah.
3 and what? 3 times 4 gives you 12. Those are factors. Somebody else said 2. 2 times what gives you 12? So 2 and 6 are another set of factors. A factor is just a number that you multiply by. That's all that is. So like factors of 12, you could say 2 times 6, 3 times 4. We're just talking about numbers we multiply by. So y'all need to write that, because some of y'all looking at me confused. Number you multiply by. So I'm going to start us off with an example. I'm going to write down an exponential equation, and we'll actually use the one we had from up there. That's the same one I wrote earlier. Who can tell me what my initial value will be for this equation? Oh my God, so smart. The initial is 3. How much are we multiplying by each time? 2. The factor is 2. That's it. So right now, all I'm asking you is what is the initial, what is the factor? I just want to make sure y'all don't mess it up and you can tell me the right thing. All right, let's try another one. Don't make it complicated. I see your face. You're already trying to make it complicated. I'm not asking you to do anything yet. I'm just asking you for the initial and the factor. I'm just making sure we can identify the parts before I actually teach you something today. Don't make it confusing. You know I always start off real easy. Then we step it up, which Curtis hates. All right, be careful on this one. What do you guys think the initial would be if there's nothing out front?
1.
Oh, yes, you 3, extra credit. It is not 0. Good God. If I ain't taught y'all nothing this year, it's that it's not 0. Y'all stay saying 0 for stuff. There is something sitting out there. You just can't see it. Remember, it's an understood 1. Now, what are we multiplying by each time in this equation? 1/2. Very good. All I'm seeing is, can you tell me the initial and the factor? Is everybody okay with that one? Okay, so I'm gonna step it up. Curtis, this is your favorite part. So we're gonna flip. I'm gonna flip. You may not have to. Y'all might write smaller than me. So for these next examples, what I want you to do is identify each table as linear. Oh, I spelled linear wrong. Linear or exponential. Then write the equation. And this is the last thing we're going to do today. So y'all really hang with me on this last part, because these are the 2 main important things to learn. And we'll pick up with this tomorrow. All right, y'all. We're going to look at the table and figure out, is it linear or is it exponential? So what I need y'all to remember on the front, what kind of pattern did we say linear functions have? Then look on the front if you got to.
And adding.
Good, adding. What kind of pattern should exponential functions have?
And multiplying.
Multiplying. So y'all, let's look at table 1. I hope we're paying attention, because this is what you're doing on your homework. If you look in table 1 and you look how we get from each number to the next, what pattern do y'all see? So how do we get from 2 to 5? How do we get from 5 to 8? What do y'all see? Good. Oh, y'all are so smart. +3. If we are adding 3, what kind of function is number 1?
Linear.
A linear. So when we write the equation for a linear function, what should it look like? mx plus b. So we're going to write the equation in a minute. Very good. Y'all already know how to do that, right? God, I hope so, because we spent almost 2 months on it, right, Curtis? Uh-huh. Now, let's go look at table 2 before we talk about how to write the equations. If you try to get from -3 to -9, I want y'all to watch this. Tay, make sure you're with me, boo. And then you try to get from -9 to -27. And then you jump from 27 to 81. Do y'all see how those numbers are getting big really, really quick?
Yeah.
It is probably not linear. That doesn't look like the same pattern to me. So does anybody see if there's something we're multiplying by? Oh, smart. She blurted that out. All right, look. Do y'all agree it's multiplying by 3 each time? All right, if it has a multiplying pattern, what kind of function is it? Exponential, which means, and I'm going to abbreviate if that's okay with y'all, exponential. What will the equation look like when we write it?
A times bx.
Very good. Y'all are so smart. Good job, y'all. A times b raised to the x. It's not bad. You look at the pattern. Is it adding? Then it's linear. If it's multiplying, then it's exponential. Okay? So let's start with the linear one for writing the equation, because y'all should know what this is. What's the slope of the linear one? What are we adding each time?
3.
3. And if you look at the left side, remember 3 over 1, because that's adding 1 each time, right? Y'all remember doing this? Okay. So it would be y equals +3 over 1x This is where I think we might not remember, and that's okay. Plus, how do we find the base? Oh my God. Extra credit, 3 points on your test, because that was a good answer. Say it again. It'd be nice if you said it loud so they could all hear you. We go backwards. Everybody look. Remember the initial amount. The base is where the x is 0. So do you guys remember in unit 1 working backwards to figure out what goes with 0? Listen, pay attention to me. Because y'all the kids next week that ain't going to do your work. Except for Amaya and Kiera. And some days Curtis and Chandler. And Carter. And Jay sometimes. You don't be doing your work. Don't lie. Instead of adding 3, work backwards. What do we do?
Minus 3.
What'd you say? Opposite, which is to subtract 3. Thank you. Everybody look. What is -1 minus 3? No. No, they have the same sign, add the flipping numbers. What is 1 plus 3?
Four.
Jesus Christ. 1 minus 4. Thank you. Woo. It's not funny. My 7th grade niece can tell me that's -4. It's okay, but this is why I'm telling y'all you need to do your work, because about half of you are going to be sitting in Math 1 again next year. And I will make sure you get Miss Harris. Listen, pay attention. Is everybody okay with the linear one being y equals mx plus b? And we got 3x minus 4. All right, let's look at the exponential, y'all. We're going to do it the same way. So with the exponential, what I need y'all to remember, what does the A stand for? You can look at your notes. The initial, good job, extra credit. Again, you're killing the game, girl. This is why I get so mad at you when you don't do your work, because you're smart. A is the initial. Can you see the initial in this table? No. No. Curtis, what'd we do over here to find the initial, boo? Tell them. Go backwards. Thank you, Amaya. So everybody look. You didn't know. Yes. Listen. Listen. We got to work backwards. The initial is where it's 0. Terrence, are you with me, babe? I hope so. I can't see you. Okay. If you work backwards from multiplying by 3, what would be the backwards or the opposite?
Divide.
Y'all are smart. Divide by 3. Good, Gwyneth. So look, y'all. What is -3 divided by 3? -1. The initial is -1. I was talking to her on the computer. -1. Y'all are getting too sidetracked today. I have a feeling y'all were just allowed to be wild yesterday. I feel like I'm having to retrain my dog. -1. -1 is the initial. Does everybody understand how we got -1? We worked backwards to find where x was 0. So instead of multiplying by 3, we divided. You okay, Carter? Okay. Now, the B, what does the B stand for? The factor. So what were we multiplying by each time, Tay?
3.
This is your equation. Do we feel like on the homework, this is all you have to do on the homework, so listen to me. I'll make sure everybody's paying attention. Do we feel like on the homework, if I gave you a table or an equation, I need to see eyes. If I gave you a table or an equation on the homework, do y'all feel like you could tell me, is it linear or exponential? Do you feel like you could write the equation? If you do not, then you need to ask me some questions while you're working on your homework right now, okay?